Hello. For this installment, we're going to start polynomials. So, what is a polynomial? Polynomial is an algebraic expression where you have constants times x to a power. The constants are a sub n minus 1, and the powers are x to the n minus 1. So the powers are decreasing in x, and the constants can be positive and negative real numbers, okay? Now, a sub n's are constants, so we have 7x cubed, 5x squared, minus 3 halves x minus 1.5. That is one example of a polynomial, okay? There are infinitely many polynomials, okay? Now, we as mathematicians write polynomials with decreasing powers of x. Now, we're also, in this class, we are going to have polynomials with two variables. So we're going to have x's and y's, or a's and b's, depending on whether we're talking about hyperbolas, whether we're talking about ellipses, or we might just have x's if we're talking about parabolas. So, that being said, how we typically in math write this is the x's decrease in powers, or the a's in this instance decrease in powers, and the b's will increase. Now, the constants can be positive or negative. In this example, we have the constants are all positive. So we have 16 ax to the fourth plus 9 ax cubed b plus 4a squared b squared plus 1ab cubed plus b to the fourth. Again, to keep things organized, we have a's decrease and b's increase. Now, distributive property is one of the most common properties in mathematics. And here we're going to distribute the a across the parentheses. So we have a times b plus a times c. That is called distributing. So when we go and we put the a inside the parentheses, I like to call that the fairness property. So what's on the outside goes to everything on the inside. If we go the other direction, so if we pull the a out, that's called factoring. That's pulling the greatest common factor out. And that's what a lot of people forget to tell students when they first teach this, is they forget to tell you that that is factoring. That is one of the most common properties that is used in all of mathematics, okay? So first we're going to distribute 2 through the parentheses. So we're going to get 2x plus 14 because 2 times 7 is 14. Next, we want to factor 4x minus 16, so we're going to factor out a 4. So we get 4 parentheses x minus 4 close parentheses. All right. Next, we want to multiply out using distributive property to expand this polynomial. Now, here's the thing. I do not use, quote, FOIL, first, outer, inner, last. I don't use it because a lot of students, depending on what your background is, they don't teach it. So what I teach you to do is I teach distributive property. So you have 2 parentheses multiplied together. So we're going to multiply the x plus 2, we're going to distribute. So you're going to have x times x plus 2 minus 4 times x plus 2. Then you're going to distribute again. So you're going to get x squared plus 2x minus 4x minus 8. Now you're going to combine alike terms, and you're left with x squared minus 2x minus 8. Now, if you're multiplying, if the directions are to multiply out these two parentheses and you can go straight to the answer, then by all means do so. I'm showing you all the steps just to remind you of your algebra, because for a lot of students in this class, it has been a while since you have seen the algebra. Okay, so let's look at another example. So we're going to multiply out a plus 2b times a minus 3b. So that's a times parentheses a plus 2b minus 3b times parentheses a plus 2b. Now, I always put the minus sign so that I'm multiplying the minus sign and distributing it to the second parentheses so that I don't forget to. All right, so when I multiply the first parentheses, I have a squared plus 2ab minus 3ab minus 6b squared. So then when I combine the like terms, I have a squared minus ab minus 6b squared. Okay? Next, we're going to talk about the difference of squares. So if I have a squared minus b squared, to multiply that out, I have a minus b times a plus b, or when I factor, I get multiplying a minus b times a plus b, I get a squared minus b squared. When I factor, I have a squared minus b squared. When I factor that, I get a minus b times a plus b. So if I want to multiply x minus 3 times x plus 3, then when I multiply that out, I'm going to get x times x minus 3 plus 3 times x minus 3. So that gets me x squared minus 3x plus 3x minus 9, which is x squared minus 9. The next property is perfect squares. Perfect squares, you're going to see a lot because we're going to be working with hyperbolas and ellipses. So if I have a minus b squared, that is a squared minus 2ab plus b squared. To multiply out, I have a minus b times a minus b. So that's a times a minus b times a minus b. So I have a squared minus ab plus b squared. So I get a squared minus 2ab plus b squared. All I'm doing on this slide is showing you where the rule comes from. You will want to go straight, and you will want to go straight and use the little a equals 5x and b equals 7 and plug it into the little formula, because we're going to start doing these a lot. Okay, and so you'll want to use the fact that I have 5x squared plus 2 times a, and a is 5x and b is 7, so 2ab plus b squared. To simplify this, instead of multiplying the parentheses out, you're going to want to use the rule, so that I'm left with that parentheses 5x plus 7 quantity squared becomes 25x squared plus 70x plus 49. You're going to want to use the rule. When we get to multiplying and expanding out a hyperbola and an ellipse and writing them from the formula to standard form, you're going to want to use these perfect square rules because it will make it faster. Okay, so next, let's look at x minus 3y squared. So what we're going to do is we're going to take the x and square it, because we're going to let a be x. We're going to take, for the middle term, we're going to have 2ab, and it's going to be a minus, and we're going to let, so it's going to be 2x times 3y, And then for the last term, we're going to have 3y quantity squared. So we're going to have x squared minus 2 times x plus times 3y plus 3y squared. Then we're going to simplify that so that we get multiply the 2x times 3y, so that becomes 6xy, multiply the 3y squared, so that becomes 9y squared. Then we put all that together and our answer is x squared minus 6xy plus 9y squared. That is a lot easier than trying to put those two parentheses together and multiplying it out. All right. Now, we're also going to be taking things from the general form and putting them back in. So we're going to have to factor some things. And so I'm giving you on the last slide some general factoring strategy. So the first thing you're going to want to do is pull out the greatest common factor. So that's using the distributive property backwards. The second thing you need to realize is that if I have a squared plus b squared, that is prime. You can't factor that. That's what it is. Third thing is check for difference of squares. Okay, so if I have a squared minus b squared, then that factors into a minus b times a plus b. The fourth thing is check for sum and difference of perfect squares. So if I have a squared plus or minus a minus 2ab plus b squared, then that's going to be a plus or minus b squared. And the last thing is to use completing the square. This will be taught in chapter 5/6. So we do it in 5, and then we do it again in chapter 6, and I combine 5 and 6 into one unit so that they're one thing together. And I'm not going to teach completing the square until we get there. That way you're not bombarded with everything right now. If you need to, you might want to go ahead and start reviewing that if you have a little bit of time now to review it so that it's not so difficult then. So if you have any questions, please let me know. I'll see you at our next installment.